So, this is a quick review of cardiovascular physiology. What happens to the body when we exercise? Reminder of how the heart works. This is a brief video that might jog your memory. This can be found on YouTube, science.tv, if you're unable to hear. The heart's there to pump blood around your body. Your blood is deoxygenated when it comes from the body to the right atrium. The atrium collects the blood and passes it on to the ventricle. This sends the blood up to the lungs to pick up oxygen. Pulmonary circulation. When the blood comes back to the heart, it's oxygenated. The left ventricle is the strongest part of the heart. It's going to pump the oxygen-rich blood around your whole body. The heart is a muscle. When we exercise, the heart beats faster. As you guys know from class, when you wear your heart rate monitor, your heart rate increases with activity. Your stroke volume will also increase. Stroke volume meaning the amount of blood that's pumped out of the heart every beat. Put the two together and you get cardiac output. The amount of blood pumped out of your heart per minute. So that can be found at YouTube, science.tv. Heart rate, the number of times the heart beats per minute. We know what happens to the heart rate when we start to exercise. It increases almost linearly all the way up to our maximum heart rate. The maximum heart rate is dependent basically on age. The training effect of exercise will cause our resting heart rate to decrease, meaning that fit people generally have a lower resting heart rate than unfit people. Fit people have hearts that work more efficiently. Stroke volume is the amount of blood pumped with each beat. It is the difference between the heart at rest and when the heart is contracting. How much blood leaves the heart with each beat. What would you expect to happen to stroke volume with exercise? Well, it goes up. Our body needs more energy, therefore it needs more oxygen, therefore we need to pump more blood to the tissues. Now, the stroke volume does not increase linearly as the heart rate did. It's linear, which you can see from this graph, up to about 40 to 60% of your maximum effort. What happens to stroke volume with long-term exercise? Well, it will increase. Fit people have higher stroke volumes than unfit people do. We put those two together and we get cardiac output. Cardiac output equals heart rate times stroke volume. So the number of times the heart beats per minute times the amount of blood ejected each beat. With acute exercise, I start exercising right now. My body needs more energy, therefore it needs more oxygen, therefore it needs more blood. My stroke volume is going to increase. Now, with long-term exercise, with chronic exercise, my cardiac output is going to remain about the same for any given activity. However, the way that I get that cardiac output will change. So at rest, my stroke volume will be higher. My resting heart rate will be lower. My cardiac output will remain unchanged. Vo2 Max is widely recognized as the most effective way to measure cardiovascular fitness. And it is measured in liters of oxygen per minute. The central component of Vo2 Max we've already discussed. It's cardiac output. The peripheral component is called Vo2 difference or oxygen extraction. And what that means is it's the difference between the blood when it leaves the left side of the heart and when it returns to the right side of the heart. So, as we learned in the video, when the blood leaves the left ventricle, it is oxygenated. Theoretically, let's say it's 100%. It travels through the body, the organs and the muscles and the brain take out the oxygen that they need, and it returns to the right side of the heart. Let's say that half of that oxygen was used, so 50%. So the AVO2 difference would be 100 minus 50 or 50, the difference between the arterial blood and the venous blood. I will never ask you to do calculations or use numbers. I just want you to understand the concept. When we look at Vo2 Max, it's a very complicated thing to discuss. These give you some of the variables that would be discussed perhaps in an exercise physiology class. For us, if we understand cardiac output and AVO2 difference at a basic level, that will be sufficient. Some of the things that will help our muscles be more efficient at taking out oxygen extraction, would be having more mitochondria, which are the powerhouse of the cell, where our body creates energy aerobically, and also increasing capillary density, meaning the number of blood vessels that travel to the muscle. So, what happens with exercise? Acutely, obviously, if we need more energy, we need more oxygen. So our VO2 will go up. The amount of oxygen, the liters of oxygen that we need to perform whatever the activity is, will go up. Now, Vo2 max simply means what is the absolute maximum amount of oxygen that our body can take in and use to create energy. That is at absolute maximal effort. Now, if you look at your chart from your homework, you can see the variable acute exercise. So we start exercising right now. Acute exercise as in we're exercising now at our absolute maximal effort. And then what happens if we exercise for 6 months, a year, 5 years? What's the training effect? So with resting heart rate, when we train, our resting heart rate goes down. Our exercise heart rate, obviously, if we begin to exercise, our heart rate goes up. However, our maximum heart rate is going to stay basically the same because age is the factor that we are using to determine maximal heart rate. Stroke volume, when we begin to exercise, will go up. At our maximal effort, it levels off. Remember that it levels off around 40 to 60% of maximal effort. The training effect, we will have a higher stroke volume if you are fit than if you are unfit. Cardiac output If we start exercising right now, we need more energy, we need more oxygen, therefore our cardiac output goes up. At maximal effort, we need maximal cardiac output. The training effect for cardiac output, it pretty much remains the same. If you're sitting in class listening to a lecture, you need the same amount of oxygen that you did 6 months ago before you started out exercising. The difference is the way that you get it, because now your resting heart rate is lower, your resting stroke volume is higher, and your heart is more efficient than it was before. VO2, volume of oxygen used, when we start exercising, we need more oxygen, it goes up. Vo2 max is the maximal oxygen our body can transport and use at maximal effort. Once again, the training effect for VO2, just like cardiac output, if we're sitting in class listening to a lecture 6 months after we started exercising, our body still needs the same amount of energy. Vo2 difference, oxygen extraction, well, it goes up when we start to exercise. Our body needs more energy, therefore we need more oxygen, therefore our muscles need to extract more oxygen from our blood. And that's also going to be raised at maximal effort. Ventilation, well, obviously, if we start to work out, we breathe more. The more intense the workout, the harder we breathe. The more often we breathe, the deeper we breathe. We're going to leave blood lactate for another day. The bottom line is that our lactate threshold, or our onset of blood lactate accumulation, OBLA, occurs at a higher percentage of the trained person's aerobic capacity. So an untrained person, it might happen around 55%, but a trained person, it might be closer to 90%, as a result of an increased ability to generate a high lactate level after training. We'll talk about that more in the future. Systolic blood pressure, the pressure when the heart is contracting, the higher number. The accepted value is usually around 120 over 80. This is the top number. When we start exercising, our systolic blood pressure will go up. When we exercise at maximal effort, it will go up. Our training effect, if we have high blood pressure, exercise may cause our blood pressure to lower. Diastolic blood pressure, that's the lower number. That's when our heart is relaxing and filling. We hope that that stays the same when we exercise. If that goes up with exercise, that is the sign of a problem. Once again, the training effect, if we have high blood pressure and we begin to exercise, often the diastolic blood pressure will decrease. And that is our quick review of cardiovascular physiology.